In this lesson, we are going to be modeling with quadratics. What does that mean? It means that we're going to be using quadratic functions to model and solve real-world situations, basically. Real-world problems, word problems that involves quadratics, right? It needs quadratics to solve. So there are so many different types of these problems. I can only do so many, but I want to show you two types today and go through these with me and see what kind of thinking you have to do, what kind of setup you have to do, and then you guys can apply that to all different types of problem, right? So the first one is the projectile motion. Here, this type of problem, they usually give you the equation, right? So here, an object is launched from 19.6 meters per second from a 58.8 meter tall platform. The equation for the object's height, s, at time t seconds after launch is s of t is equal to this crazy equation. Now you read through that and it looks all crazy, right? But it's not really. All they give you is an s and a t instead of an x and a y. That's all it is, right? What is s? S is the height. T is the time in seconds. Right, so which one is s? Which one is y? Which one is x? Which one is y? T is going to be your x, right? Because it's in the equation here. And s is the function of t. So s is your y, right? So based on that, I can make my coordinate plane. And I'm not going to label anything because it's all arbitrary. I can call this 10, 1,000, doesn't matter. I don't know what my numbers look like yet, so I'm not going to label that. But here, my y-intercept, or my y-axis, is going to be the height, s, right, because that's y. And the time is down here. And I'm just going to graph this, right? The easiest thing to graph is the y-intercept because this is standard form. That number in the back there is y-intercept. So there is 0, 58.8. That's the y-intercept. That's when the that's where the rocket was when it first launched, right? When the time is 0, when you first launch, it's that high because it's on a platform. Right? That should make sense. And then the next thing you have to do, find the vertex, right? If you have the vertex, and you can find like a lot of things. So I'm going to find the vertex to graph this. So this is standard for I'm going to use negative b over 2a. So when I plug that in, negative b over 2a, I get 2. And what does that 2 mean? That means the axis of symmetry is 2. So I'm just going to say this is 2. 2, 4, 6, 8, 10. Looks about right. So I'm going to say this is 2, and my vertex is somewhere along there. So I have to plug that 2 in and find s, right? So f of 2, instead, it should be s of 2 instead of f of 2, but that's a mistake. So s of 2 is equal to this thing. I plug 2 in, and I get 78.4. So there it is, 2, 78.4. That's the vertex. That's basically the maximum. Right, I want to find the next point is the x-intercept, and this is standard form. It's all crazy. I can't factor this. I have to use the quadratic formula, and I plug that in. There's all crazy stuff, but put it in. Use a calculator. It's not even bad. And then it comes out x is equal to 6 or negative 2. So here, x can't be negative, right? Because time can't be negative. You can't really consider time before the rocket was launched, right? Because it's not modeling that. It's modeling since it first launched. So you can only use the positive one, right? So there is 2, 4, 6. Yeah, 6 right there. That's your x-intercept. And then there's your graph. It looks like that. The projectile gets launched. Boom. It goes up and then it goes down, right? And this is not the physical projectile, right? This is the height according to time. So this is not the distance. This is time. So as time passes, the height changes. But it might be going in that direction. Or it might be going in some weird direction. We don't know that. But the height is going up as time goes up into 2 seconds. And then after 2 seconds, the height goes down. So it could have just gone straight up and straight down. We don't know that, right? But once you have this, you can answer all kinds of questions, right? So, oops, that number got switched. So that should be 78.4, comma 2. But I made the mistake there. Wait, no, that's right. Nope, never mind. That's right. I fixed that. So based on this, you can answer all kinds of questions. So at what time did the rocket reach its highest point? Highest point is when the height is at maximum. So at this point, what's the time? Time is the t variable, right? So that's 2. So 2 seconds. Okay. What is the maximum height? Well, that's the y part of your vertex, because y is your height right there. So that's 78.4 feet. Okay. At what time did the rocket hit the ground? Right here. 6 seconds. Okay. At 6 seconds, the height is 0. That means it hits the ground. And then how far did the rocket get launched from its platform? Like basically asking for the horizontal distance. We don't know that. There's no way to find out. That's not part of the equation. The equation is only about time and height. You don't know how to find the horizontal distance. Okay. Now, at what time did is the rocket 60 feet above the ground? So 60 feet, you have to put 60 into the height, right? Because they give you the height. They're asking for the time. So you have to put 60 in, right? So you're looking for these points here where y is 60 and you're looking for x. And you put 60 in for y, basically, or for height, and you're looking for time. And then from there, you subtract 60 from both sides, and you solve using quadratic formula, and you get that. Okay. Um, so here is the area type of problem. So imagine, suppose a farmer has 1,000 yards of fencing to enclose a rectangular field. What is the greatest area that the farmer can enclose? So in this kind of problem, you have to kind of visualize it. So I drew a field out here for you so that you can draw the fence around it, right? Kind of visualize what's happening. So in a fence, you have, which is called the width x, right? If this is x, what is the length here? So the whole thing has to be 1,000. So the length and the width has to be 500. So if this is x, this has to be 500 minus x. Okay, I hope you guys get that. Okay, because this plus that has to be 500. All right, so that has to be 500 minus x. And then based on that, you can just do the area. It's asking for the largest area. So area is equal to length times width, which is this times that. Okay, and you multiply it in, you get standard form, negative x squared plus 500x. And x is how long the width is, right? Easy enough. Now, you got to think, what does a quadratic have to do with a freaking rectangular field, right? This is a rectangular field. Why is it a quadratic graph? If you graph it out, you will see. So this is your y because, it's a function of x, right? So it's y. X is over here is your width. Okay. And then you're going to graph that. This is also standard form. And your y-intercept is 0. So there is 0.00 because there's no number back here. And then you do x-intercept. This is easier to do x-intercept because you could factor it. I factor it out. This is factor form, you see? A factor times a factor. So I put 0 is equal to that. Then x has to be 0, or 500 minus x have to be 0. So x comes out to be 0 or 500. So these are my x-intercept, 0, 0, or 500, 0. Then in between has to be my axis of symmetry, which is going to be right here. Between that, it's going to be 250. So my vertex is I have to put 250 in, and I find the vertex, right? And that comes out to be 62,500. So there's that point. At 250, I get 62,500. And then there is my graph. Okay. Now let's think about this. Why is it a quadratic? What does that have to do with the with a rectangular field? So here is basically width is how big this side is, right? So if that side is 0, if you put it 0, so the field is like really flat, like 0 for width, right here. The area is going to be 0 because it's so flat. There's no area. It's just a line. Now, if you bring the width up, the width gets bigger and bigger. The area increase, right? Up to a point where if this is 250, that's the maximum you can get. And then if you get wider and wider, the field gets like narrower and skinnier and really skinny. And if it gets to 500 and then 500 back, that's 1,000. See, it's just a line, so it becomes 0 for area again. So this is a function. Area is a function of how long this is, right? As x goes up to 250, the area gets bigger. But if x gets bigger than 250, and bigger, the area comes down. Area comes down.